Okay, good morning everyone. We'll discuss in this session classification of soils. We have solved some of the problems, but we'll see uh, problems from the question paper now today. Just to revise what we have ready references as far as IS classification IS 1498 1970 is concerned. Classification symbol has to be given in this manner, in this way. That is the classification. GW, when we say it is gravel well graded, GP is gravel poorly graded, GM is silty gravel, GC is clayey gravel, SW is well graded sand, SP is poorly graded sand, SM is silty sand, SC is clayey sand. Now for this, what are the conditions or criteria to be satisfied? First of all, to classify it as gravel, percentages will be helping you. To say it is well graded, Cu has to be greater than 4, Cc has to be between 1 and 3 after grain size analysis. GP not meeting these conditions, it will be. One more condition is, if you want to classify this, your fines, means the percentage of particles less than 75 microns have to be less than 5%. If percentage of particles, fine particles is greater than 7%, in that case it will be GM or GC. The helping guideline would be IP less than 4, then it will be silty, IP greater than 7, it will be GC. If IP is between 4 and 7, then borderline cases are requiring use of dual symbol. That is two symbols like GW, GM, like that. There will be combination of classification symbol for IP between 4 and 7. Similarly for sands also, between IP between 4 and 7 you have a dual symbol. Otherwise, if you want to say that it is SW or SP in both these cases, SW and SP in both these cases, the percentage of fines will be less than 5%. Cu is greater than 6, Cc between 1 and 3, then it will be well graded. If it is not satisfying any one of these conditions or both the conditions, then it will be SP. Then if percentage of fines is more than 12% and IP is less than 4, then it is silty. And if IP is greater than 7, then it will be SC. Right? More than 12% if the fines are, then it is GM, GC or SMSC. Here it is very clearly mentioned. Determine percentage of gravel, sand from grain size curves depending upon the percentage of fines, that is fraction smaller than 75 microns. Coarse grain soils are classified as, if the fines are less than 5%, then it will be pure gravel or sand. More than 12%, then it will be silty or clay. If between 5 and 12%, then it will be borderline classification. Okay. So Cu, you know the formula, D60 by D10. Cc is D30 square divided by D10 into D60. That is coefficient of curvature. Okay, we'll see the problem. This is December 2014, January 2015 question paper. Classify the following 3 soils as per Indian standards. They say they have given the data. Soil, there are 3 soils, 1, 2, 3. Gravel percentage they have given. We'll go one by one. Soil number 1, percentage of gravel is 1, percentage of sand is 98. Then percentage of clay is 2. How can it be? Something is wrong. Anyway, maybe 1%, let us say. So most of the percentage is sand, right? Obviously the overall classification will be sand only. If it is sand, then Cu should be greater than 6. Cc should be between 1 and 3. Yeah, it is satisfying both the conditions. There is no question of liquid limit and plastic limit because it is a coarse grained soil. Okay, so that's why soil 1 is pure sand with good gradation. It is classified as well graded sand. Yeah, you can just look at the data. It is sand. Cu is greater than 6. Cc is between 1 and 3. That's why it is well graded sand. Now look at the soil number 2. Gravel is 1%, sand is only 9%, 9 plus 1 10, remaining 90% it is all clay. They say it is clay, but how they have found that it is clay or silt, anyway the data is given. So because more than 50% of the soil is clay, it is a fine grained soil. Fine grained soil in the sense it will be clay or silt. Only thing is, so whenever we say clay or silt, it is CRM, but classification should carry one more letter along with this. The letters are L, I and then H, depending upon whether it has a low compressibility or intermediate compressibility, medium compressibility or high compressibility. This is with respect to plasticity chart. Anyway, soil number 2, they have got one more data, liquid limit and plastic limit also. From that I can calculate IP, which is a difference between liquid limit and plastic limit. It is 45%. Then what I have done is IP on A line. If you recall, A line is like that. The equation of this line is 0.73 WL minus 20. WL is given, liquid limit is given minus 20, so 0.73. So liquid limit is 65. On this x-axis we plot liquid limit. So this is now 65, it is given. Now if I work out a value over here, that has come 32.85, means the corresponding to this, whatever IP I have here on this axis, I have plasticity index. Okay, on this line the value that I have got is 32.85, but actual IP is 45, means the point is falling above this. Please note this discussion. Liquid limit is given 65. Fine. Using that I have found IP value on A line. This is important. IP on A line is 32.85, means the value at this point is now 32.85, but actually the soil has got IP as 45, means it is not 32.5, it is falling above, means somewhere there the 45, let's say this is 45. Okay, now you have for classification, here there is a 50, so liquid limit is beyond 50, so there is a vertical line over here. I missed that vertical line. So vertical line is 50, so this point is beyond 50 to tell that it is of high compressibility and it is above A line, that's why it is clay. So soil falls above A line, that's why it is clay. Liquid limit is 65%, which is more than 50%, that's why it is highly compressible. Hence the classification symbol is CH, that is clay with high compressibility. Okay, now soil 3, it is gravel is 0%, sand is 86%, clay is 14%. Okay, here 86% is sand, because of that straight away, hence the soil is sand. Very simple. But percentage of fines is more than 12%. More than 12%. Right? That's why this is not pure sand, right? And moreover, no information is given as far as the CU and CC is concerned. But clay percentage they have given as 14%, so that we can simply say that it is clay sand, right? With percentage of fines 14%, more than 12%, it is clay. Hence, classification symbol will be simply SC, or clay sand. That's how you can give the classification though. So in such problems, end expressions SW, CH or SC, these symbols are important to be mentioned. Okay, let me go for the next one. Okay, straight away the problem is given here. Here percentage passing through 4.75 is 70%. Percentage passing through 4.75 is 70%. So to say, what percentage which is greater than 4.75 is 30%? That is gravel percentage. Okay, percentage finer than 75 microns is 8%. Percentage finer than 75 microns is 8%. Now 70% minus 8, that is 62%, is sand. Alright, because 30% goes as a gravel. If I have to write here, now gravel becomes 30%. You can just see that it is because percentage finer than 4.75 is given 70%, so greater than 4.75 is all gravel, that's why it is 30%. Percentage of fines, it is given that it is 8%. So from this data we can analyze for sand percentage, which is obviously 100 minus 38, that is 62%. So 62% is sand. That's why the classification will be it is sand. They have given CU and CC, so it is more than 6 for sand, CU greater than 6, CC in 1 and 3. Obviously it is well graded, so it is a well graded sand. SW would be the classification symbol. Okay, but percentage of fines is 8%, right? More than 5%. That's why it is not just SW, right? It has got a mixture of silt or clay also. Now for that you have to refer to IP, right? Now percentage of fines is 12%. I mean not greater than 12%. Because of that, directly it cannot be just SM or SC, not this, right? If percentage of fines is 12, more than 12%, it would have been either SM or SC, but it is between 5 and 12%. So this percentage is between 5 and 12%. That's why there is a dual symbol. Now as fines are between 5 and 12%, it is borderline classification. As IP is equal to 3, they have given it is less than 4, so it is SM. Just now we have seen in earlier slide that IP less than 4, then it will be silt. IP greater than 7, then it will be clay. So that's why SM. Hence the classification symbol will be dual classification symbol. So it will be SW-SM. So it is showing well graded sand performance also, but because of percentage of silts, it is SM also. That's why classification is SW-SM. That's how the classification is done. Now next. Okay, one more problem in which again the data is given. I don't have the exact question paper here, but anyway, this data is given. Soil A and B, there is plastic limit, liquid limit, flow index, natural water content, and then plasticity index is calculated, because 16, 30, 24, 19, 52, it is 33. This is worked out quantity IP, because we have given plastic limit and liquid limit. One can calculate IP. IP is WL, or liquid limit, minus plastic limit. Okay. Now the comment on all these soils, because you can compare this, because plasticity index for B is more than plasticity index of A, we can say that soil B is more plastic than A. Okay. Now consistency index IC, which is given by WL minus W divided by IP. IP is nothing but WL minus WP. Okay. Now IC is coming out to be negative, in the sense this value is less than plastic limit. Natural water content, obviously natural water content, you can just see here, for A is more than plastic limit. That's why it is coming negative. This turns into slurry when remolded, means water content is a bit more. Because of that, when it is taken and then mixed with the hand, remolded, in the sense it becomes slurry when remolded. Okay. Again, the same consistency index for B, 52 is liquid limit, minus 40 is natural water content, divided by 33. So this is coming out to be positive. Here what it indicates is this value, or natural water content, is less than liquid limit. It is there, you can just see here. That's why this is coming to be positive. This is suitable for foundation, or good, it can withstand some load or something like that. Okay. Now flow index 11 and 6. Flow index A is greater than flow index B, so we can say the soil B has better shear strength than soil A as function of water content. Okay. Then toughness index, IT, toughness index is equal to IP by IF, it is 2.18. IT of B, toughness index of B, formula for this is IP by IF, calculate 5.5. Comparing these two, the soil B has better shear strength at plastic limit. Soil B has better shear strength, means toughness index indicates the shear strength at plastic limit. That's what you can observe. Now as far as classification is concerned, the soil A is clay, obviously, right, with less or low compressibility, because liquid limit is falling less than 35%. Liquid limit is lying less than 35%. In this case, liquid limit is going beyond 50. So beyond 50 it is high compressibility. Anyway, it is given to be clay data, so it is CH. So when plotted on plasticity chart, you can classify A as CL, clay with low compressibility, B as CH, that is clay with high compressibility. Okay. Next, classify the following soils with IS system. What data they have given is soil A is has liquid limit 38%, plastic limit 20%. So I can calculate IP plasticity index as 18%, 38 minus 20. Okay. Now IP on A line, if I calculate with 0.73 WL minus 20, it is 13.14. right? Actual value is 18%. So the soil lies, hence the soil falls above A line. That's why it is clay. Above A line, that's why it is clay. Now, as liquid limit is between 35 and 40, you can just see here 38 it is between 35 and 40. So obviously it is medium compressibility. So the classification goes as CI, that is clay with medium compressibility. Hope you have understood this discussion. They have given soil B, liquid limit 18, plastic limit 12. As usual, I'll calculate IP. It is only 6% and the liquid limit is 18%, which is lesser than 20%. Hence, it is of low compressibility, right? Because you should remember that graph. Then one at 35, one at 50. Okay, here liquid limit is 18%, means this is 20. 18% means somewhere there, and soil will be falling some in this region. That's why it is having low compressibility, right? IP is 6%, so it is between 4 and 7. You know that here there is 4 and 7, so it is between 4 and 7, hence it falls in a dual symbol region. The soil classification symbol will be CLML. You know that there is a hatched region here indicating CLML between 4 and 7 the values, so it is in that region. So the soil is classified as CLML. Okay, there is one more, soil C. Passing through percentage passing through 4.75 is 70%. So to say, gravel is 30%, percentage of fines is 8%, 70. Again, 62% is sand. So in this case, sand is 62%. I think I might have worked out. Yes, percentage of gravel is 100 minus 70, 30%. Percentage of sand is 70 minus 8, that is 62%. Hence, the soil would be classified as sand with dual symbol. Why dual symbol? Because 8% is the fines. If it is less than 5% and greater than 12%, then it would have been direct. But because fines is 8%, between 5 and 12%, soil would be with a dual symbol. So Cu greater than 6, okay, they have given that. Cc is 3, it is well graded sand. IP is greater than 4, it is 5%. IP is greater than 4, hence clay content is more. The classification would be SWSC. Okay. Here there is following results are obtained from laboratory tests conducted on two soils, soil A, B. Liquid limit and plastic limits are given. Show the positions of these soils on plasticity chart and classify as per IS system. Okay. Now you have to neatly draw. I used to draw in earlier problem very rough. I could not draw it. But anyway, you should rather draw the plasticity chart. Not necessary to scale, but these red lines are important. And then what you have to plot on both the axes, that's important. So liquid limit over here, plastic limit over here, uniform distribution of the scale, right? And then one vertical line at 35% of liquid limit and another vertical line at liquid limit 50%. And from 20 there is a line like that which is having a slope of 0.73, IP equal to 0.73 WL minus 20. So that is what you have to plot. Now taking one by one, the first soil, for soil A, liquid limit is 85%, plastic limit is 45%, so WL is 85. Plasticity index, which is not 45, for A it is 85 and 50, so 85 minus 50, 35% is the plasticity index. Now if I have to plot this data on this line, you can just see here 85 is liquid limit, 35 is IP, so the point falls there. You can observe that that is the position of the point. So what you can classify, it is below A line, that's why it is silt or organic soil, and it is beyond 50%. Liquid limit is beyond 50%, that's why it will be highly compressible. Okay, so that's why the soil is silt or organic soil with high compressibility. So when you are below the A line, it can be MH or OH, so that you should define both. Either it is silt with high compressibility or organic soil with high compressibility. That's how you can classify soil A. Now we shall take soil B. It is given 45 and 12, so WL is 45. 45 means it comes between 35 and 50, somewhere there. IP is 33. Now if I have to plot, that's where it falls. The point will be somewhere there. So 45 and 33. So this region is meant for CI because it is between 35 and 50 and then above A line. So that's why this will be clay with intermediate or medium compressibility. So the classification goes as the soil is clay with medium compressibility. Okay, one more problem. The properties of soil is determined from the laboratory. They have given all. They have said here it is not just classification. The plasticity indices, determine the plasticity indices and classify the soil, determine the liquidity indices and classify the consistency. That's how they have given. We'll quickly solve one by one. As far as soil A is concerned, it is fine grained soil. Why? Percentage finer than 75 microns is more than half, 55%. Obviously it is fine grained soils. Okay, now IP, if I calculate, it will be 114 minus 42, that is 72. But IP on A line, how to calculate? You know that it is the equation 0.73 WL minus 20, that comes out to be 68.62, but actual value is 72. That is to say the soil lies above A line, that's why it is high compressibility. Liquid limit is 114, so beyond 50, that's why it is clay with high compressibility. So first part, classification is done with clay with high compressibility, but liquidity index, if we calculate, which is W, natural water content they have given, natural minus WP divided by IP, it comes out to be 78 minus divided by 72, positive. So it is in liquid state. The soil consistency in natural state, the soil is in liquid state. Okay, soil B, percentage finer is look at this, percentage finer than 75 microns is less than 50, that it is 43, that's why it is coarse grained soil. So it is a coarse grained soil, but percentage of fines is 43, so it is 12%, more than 12%, so it will have clay or silt with it. Okay, so IP is equal to, if we calculate 80 minus 30, that's equal to 50. So IP of A line is 43.8, it is clay, and it will be either GC or SC, because coarse grained soil is fine, but whether it is sand or gravel we cannot say. Because of that we can say that it is GC or SC, right? Liquid limit is I mean liquidity index, if we calculate Wn minus Wp by Ip, it is between 1 and 0 and 1, hence it is in plastic state. It is in plastic state. Soil C, again looking at 47%, it is coarse grained soil. Ip is 28. A line value is 32.5, so it is below. That's why it is silty. Soil will be again GM or SM. IL is negative, indicating that the soil condition is it will be either in solid or semi-solid state. Okay, so there we'll continue, of course.